Good evening, guys. So today's demo session is on mechanical vibration, and we will be going through basics of vibration, and we will be understanding what kind of questions are expected in GATE Aerospace exam for mechanical vibration. Also, some of the questions will be taking from GATE different GATE papers like GATE XC, GATE XC, or some questions from GATE ME. Okay, so we will solve variety of the questions from basics of mechanical vibration. So in GATE Aerospace, if you see the syllabus part for mechanical vibration, we have undamped free vibration of single degree of freedom, and then we have damped free vibration of single degree of freedom. We have forced vibration for single degree of freedom. We have free vibration for second degree of freedom, and we have free vibration of continuous system. So these are the two extra topics we have in GATE AE paper, and these are not there in GATE ME or GATE XC paper. Okay, so these are the additional topics we have to study. Now references we follow for mechanical vibrations, mechanical vibration by S.S. Rao, which is one of the most standard book. And he's a Indian origin author, but he's a US based author. Okay. Then we also follow mechanical vibration by V.P. Singh or mechanical vibration by Grover. You want to have the basic understanding of vibration, then always you can refer this book. Okay. Now, what you guys mean by vibration? Anyone? Here we will discuss a brief about fundamental of vibration. So what you guys mean by vibration? Anyone? See, we want all classes to be interactive. Okay, so you guys either can respond in chat box or you can speak over audio. Okay, and as I mentioned, classes we will be keeping very simple, whiteboard teaching or teaching through PPT template. Okay, now what you guys mean by vibration? So if you have any motion about a mean line, like to and fro motion about this line is what? A vibratory motion. Like this is why my mean line, and motion an object is going in this direction, coming back, then it's going in opposite direction, coming back to mean position. So this to and fro motion is basically what? Your vibration. Okay, or vibratory motion, to and fro motion. Okay, now this to and fro motion you can understand by simple example of swinging of pendulum, right? You guys have done some experiment in your physics, right? You guys have done, right, some experiment in your physics. So there you will use one pendulum. Okay, you will use one pendulum and you do experiment, right? So this pendulum is uh, having motion about this midline like this. So this to and fro motion is what? A vibratory motion. But in a body which is undergoing deformation, and when vibration will happen in a structure, anyone, under what kind of loading you will have? vibration or will have vibratory motion? Anyone? In what kind of loading? If your load is time dependent, if my applied load, my forces, if my forces are time dependent, so when you have time dependent forces, then your response will be also time dependent. What is the meaning of response, guys? What is the meaning of response will be time dependent? Anyone? See, when you apply forces on a body, it will deform. So when your force is static, your deformation will be independent of time. Okay, when your force is static, your deformation will be independent of time. But when your force is time dependent or dynamic load, then your deformation will be dependent on time. So your response is what? Time dependent. Okay, so basically first we understand free vibration, and after free vibration we go to forced vibration. Okay, so in free vibration, what is the free vibration, guys? Anyone? What you guys mean by free vibration?
Response is not dependent on time.
What? Can you be a bit louder?
Response is not
Formation is
dependent on time.
independent of time.
Hmm? No, I can't hear you guys. One moment. Let me increase the volume of my system. Yeah, can you speak now?
Deformation is independent of time.
No, no, no. That is not free vibration. Okay.
Without any external
No
means.
friction or
Yes, yes, yes. A to and fro motion under no external force is what? Free vibration. Or suppose you take the case of pendulum again. What we can do, right? We take pendulum, okay? And guys, from mean position, you pull it and then make it free to move. So this pendulum will do to and fro motion, right? So this is known as free vibration. Okay, once you pull it and then release it to have motion, so this is known as free vibration. Clear? So the elastic vibration in which there is no friction or external force after initial release of body are known as free or natural vibration. Clear? What is the free vibration? Yeah, vibration that occurs naturally is what? Free vibration. Now guys, in free vibration also, will your response will be function of time or not?
it's independent.
It will be independent. Anyone saying independent? No, man. In free vibration also, your response will be time dependent. Okay, it will be time dependent only. Your response will be time dependent because the motion is what? A dynamic motion. Whenever motion is dynamic, then your response will be also time dependent. Now, what is the damped vibration? Anyone? These are the basics of vibration. Okay, we are discussing some basics of vibration. So free vibration. What is the damped vibration? You guys have seen your door in home. Door have some dampers, right? You guys have seen, right?
Yes, sir.
Yeah. So there, why we use the damper? To damp the motion, right? Okay. When you pull and push, your door need to get stopped, right? So that means the motion has to be died out. Is it clear? Or in many places, like your landing gear, there also you use damping. Or if you take any other mechanical system, many places damping is required. Why? If you want to stop your vibratory motion, you need to have a damping. So that the damping can be many type. It can be environmental damping, it can be structural damping, it can be like viscous damping, or you have Coulomb's damping, like damping due to friction. Clear? So damped vibration means what? When the energy of the vibrating system is gradually dissipated by friction or any resistance, the vibration are said to be damped vibration, and the vibration gradually goes and the system rests in its equilibrium position. So clear? And in your gate exam, this damped free vibration is very important. Okay. Have you guys heard about logarithmic decay? Anyone? Have you guys done this vibration course in your BTech? Logarithmic
Sir.
decay. So every year, almost every year, you will see the questions on logarithmic decay or some other questions from damped free vibration. Okay. So damped free vibration is very important in your gate exam. Now, what is the forced vibration? Anyone? When your vibration happening under any external excitation, then the vibration is what? Forced vibration. Okay. So when a repeated force continuously acts on a system, the vibration are said to be forced vibration. The frequency of the vibration is said to be is that of applied force and is independent of their own natural frequency of the vibration. So where you see this kind of forced vibration, you guys are aero guys, right? Where you guys see the forced vibration, can anyone give one example? You guys see your aircraft engine, right? It is like this. So there are many components attached to aircraft engine, right? An engine is one of the mechanical system which vibrates heavily, right? Lot of vibration happens in engine, right? So what will happen? That vibration will be transmitted to supporting components, right? Attached components. So those attached components will undergo forced vibration. Clear? At different section of your engine, there will be different RPM, right? So there will be different excitation, the frequency of excitation. So this forced vibration is also very important in a practical cases or in a practical design of components, because in your engine, with your engine, many components will be attached. Specifically what? Have you guys heard about aircraft systems?
Yes, sir.
So all the system will be attached to what? Your engine, right? And mostly aircraft systems are what? Those will be tubes, right? There will be many tubes in aircraft systems. Okay. You have fuel system, you have hydraulic system, you have air system, many systems, right? So those tubes will be highly prone, to go under forced vibration, or there are gear system, okay, or any other thing which is attached to your engine, and those components are what? having less mass. So mass is less. So what will be happening? When you have less mass, then what? Your inertia is less, right? Then that component will vibrate easily. Am I correct? Okay. So with less excitations also, it will start. And then what we usually try to do, anyone? What is the resonance? Anyone have heard about resonance? Resonance in vibration. What is same frequency? The natural frequency of the system becomes equal to what? Excitation frequency. Then resonance happen, right? It becomes equal to what? Excitation frequency. So in that case, resonance will happen. Have you guys heard about one breeze? Right? What is the excitation? It's a forced vibration. Say excitation, what is the meaning of excitation? The English meaning. Something is exciting. Okay. So in forced case, forced vibration, we call the frequency as a excitation frequency, which is causing the forced vibration. Okay. Now guys, next thing here, in basics, what we will study forced vibration. When we go to forced vibration part, what is the periodic motion? Simple term, you guys know what is the periodic motion? A motion which repeats after equal interval of time is what? Periodic motion. An example is what? Simple harmonic motion. What is the time period, anyone? Time taken to complete one cycle of vibration is what? Time period. What is the frequency, guys? Which is very important. The number of
per second, sir.
yeah, number of cycles per unit time is what? Your frequency. Now guys, what is this F and omega? See, omega is known as natural frequency, and this is also natural frequency. This is omega n is what? Natural frequency. Okay. So what is the difference between omega n and Fn? We know always omega is what? 2 pi into F. So there is the only difference of what? Unit. If your natural frequency is given in terms of omega, then unit will be radian per second. If it is given in Fn, then unit will be hertz. Clear? So this is where, many times people do mistake. What is given in your exam, that you have to understand, is it given Fn or it is given omega n? So then what is the amplitude, guys? The maximum displacement of a vibratory body from a mean position is known as what? Amplitude. Now the next is what I was discussing about natural frequency. So what is the dynamic characteristic of a system? Anyone? Natural frequency is known as there is no theoretical difference, okay, as such. It is like you denote it, the number of cycle per unit time is what? Fn, okay, in hertz. And if you want to write in terms of omega, it is 2 pi into F. Now natural frequency, basically natural frequency is known as dynamic characteristic of the system. Any system you design, you need to know natural frequency. Anyone, why we want to know natural frequency for any system which we design? Any reason to find natural frequency for a designed system? When you design a system, you need to know, yeah, to avoid resonance. To avoid resonance. That means that system will be attached to a some component which may provide X, so that there will be no resonance. Yeah, we want to avoid resonance. If resonance happen, failure will happen. Have you guys heard about one breeze? On top of that breeze, some soldiers were walking and it got fallen, right? Have you heard about that
Yes, sir.
accident? Why it fallen?
It reaches resonance, sir.
Exactly what happened. The frequency, natural frequency of marching soldier got matches with natural frequency of the breeze, so that breeze got collapsed. So that's how, that is the uh, you know that is how resonance is dangerous. Okay, so natural frequency is very important thing everywhere. Okay, wherever you design a system, first thing in dynamic, what we find, natural frequency of the system. So it is also known as dynamic characteristic of the system. And your natural frequency is independent of load. Either you apply any load, your natural frequency will not change. Once you decide a system or design a system, your natural frequency will become fixed. Okay, so it is independent of, why we multiply 2 pi f. See, this is what omega n, and it is 2 pi f. So 2 pi is more related with a cycle. Okay, it is something which is related with cycle. Okay, a complete cycle of motion. Okay, now already we have discussed about, it is the frequency of the free, and also this natural frequency is what, the frequency of the free vibration. Okay, and resonance we are already talking. So what is the resonance? When frequency of the system becomes equal to natural frequency of the system, so then resonance happens and the amplitude of vibration becomes excessive, so your system will get collapsed. Now damping, already we have discussed the damped vibration. So damping is what, the resistance to the motion of vibrating system is what, damping. Now next thing after this, the next thing after this comes is what, degree of freedom. So what is the degree of freedom, anyone? What is the degree of freedom?
Ability to move.
It is the ability to move.
Rotation around the independent axis. The rotations around the independent axis.
Is what degrees of freedom. Yeah. So degrees of freedom is basically is what, the number of independent displacement required, to specify the complete motion of the system. The number of independent, one moment guys, yeah. So what is this degree of freedom? The number of independent coordinates required to specify complete motion of the system is what, degree of freedom. So what I mean, see, you can see this is a spring mass system, a single spring mass system. Now, if you want to specify this complete motion of this, how many independent displacements are required? Anyone?
Sir.
Hello, yeah, you were saying something?
One.
One. So here the degrees of freedom will be what? 1 in this case. Now in second case, you can see this system. So here how many degrees of freedom? You can see there are two masses. Okay, they can move independently. They can do independent motion when they are not connected. Okay, so to define this complete system, we require two independent displacements. Okay, so the degrees of freedom, if you see here, there will be 2 degrees of freedom, or it is a system of second degree of freedom. Clear? So the degrees of freedom is associated with the number of independent displacement required to define complete motion of the system. Now next, once you have multi degrees of freedom system, then what is the continuous system? So what is the continuous system? Again, there are questions in gate A from this. What is the continuous system, guys? Anyone? If the number of degrees of freedoms are infinite, the system is said to be continuous system. What is the example? Cantilever beam. Okay, for a beam, the number of degrees of freedom is what? Infinite. Why infinite? Anyone? You can see every
There are many number of
section.
nodes.
Yeah, there are infinite number of small masses you can. Okay, so there will be infinite degrees of freedom associated to each mass, distributed mass. Clear? So this is what? Continuous system. Now next, one moment. Yeah. Next thing which we need to discuss is about what guys? We need to discuss about your response of undamped free vibration of single degree of freedom. There are several questions in GATE Aerospace from this undamped free vibration of single degree of freedom. So guys, to understand this response of single degree of freedom diagram, this system, what we need to know, something called free body diagram. Free body diagram, okay, of dynamic system. Free body diagram of dynamic. So have you guys heard about Newton's second method? Have you guys heard about Newton's second method? So what Newton's second method says, see, if it is a displaced, if it is displaced from its equilibrium, if mass is displaced from its equilibrium and released to vibrate, what will happen? You will see there will be one force which is opposite to the motion, and it will be what? Inertia force. Then your spring will also oppose this motion, so there is one force, spring force. Is there any other force? Anyone?
Weight of the mass. Weight of the
No, exactly. You will say weight of the mass. But what will happen? Weight of the mass will be in equilibrium from your static condition, initial static equilibrium. What it mean, guys? Anyone can tell? The initial static equilibrium, what will happen? When your mg is acting downward, what will happen? There will be some displacement, okay, of mass, and your mass will become stable in that position. So this displacement is what? Delta. It is what? Delta. You can see this delta is what? Your static deflection due to mass. Okay, here. So in static equilibrium position, your k times delta. What is k times delta? Anyone? What is k times delta?
Spring force, sir.
Exactly, spring force. So your k times delta will be equal to what? Mg.
mg.
Clear? So if you draw free body diagram, if you write your mg component, then you have to write this k times delta also. Is it clear? If you draw the free body of this mass which is in motion, okay, so mx double dot is what? Your inertia force. Kx is what? Your spring force. If you write mg, then you have to write additional kx plus k delta. Is it clear?
Yes, sir.
So usually what we do in dynamic equilibrium, we do not consider this mass components. The force component due to mass is not considered because by default it will be in equilibrium from static. Okay, your k mg and k delta will cancel. Fine, guys, or not? This point. So whenever you use Newton's method, we will talk only about what forces. We will talk about inertia force. We'll talk about inertia force. And we will talk about spring force. Okay. And this is for free vibration. If your vibration is damped, so in that case, there will be one more force. What it will be, guys?
Damping force, sir.
Yeah, damping force. Yeah. And if your vibration is forced vibration, then
External force.
yes, there will be additional external force. Okay, so this is what. Now, what is the equation of motion when we draw the free body, guys? What is the equation of motion? In this case, there are two forces, mx double dot and kx. So what is the equation of motion? It is mx double dot,
Kx.
yeah, is equal to 0. So this is what the governing differential equation for single degree of freedom system and for spring mass system. So now, guys, once you know this equation, it's what? A differential equation. What is mx? Where it's mx? It is mx double dot. It's the inertia force. X double dot is what? Your acceleration. You know what is the mass into acceleration? Is what? Inertia force, right? Okay, fine. So we can find the solution of this equation, right? And now you can see this x double dot plus k by m into x equal to 0. So what is this equation? This equation is analogous to your equation of simple harmonic motion. Am I correct? Because we know from our 11th or 12th physics, my equation of motion for simple harmonic motion is what? X double dot plus omega n square x is equal to 0. So what is omega n here, guys?
Natural frequency, sir.
Yeah, it is the natural frequency of this system. What is the solution for this equation, guys? What is the solution for this equation? It can be written in this form: x equal to capital X sine omega nt plus phi. Okay, or it can be written as what? A cos omega nt plus b sine omega nt. Now tell me, guys, what is A and B here? What is A and B? These are constants, and this constant can be found from boundary initial condition. Okay, what is the initial condition you guys can have here? Initial conditions, anyone? Like what is your at t equal to 0? At t equal to 0, what is your displacement? What is your velocity? These are your initial condition. The reason behind using spring in avionics. I didn't get what you mean by Abhiram. Okay. In avionics, you will have similar concepts, not spring. Okay. Now, in control also, you will have a lot of vibration kind of equations, similar equations. Okay. Now here, either this can be the solution for this equation, or I can write in this form. So what are my unknown here? If I write in this, then A and B my unknown. If I write, because I can write this same equation in this form. It is just different representation. So my capital X is what, guys? Is the amplitude of the response. What is your phi, guys? Anyone? It is phase angle. It is what? Phase angle. Now, guys, how we can find phi and x? As I told, from this initial condition. From initial conditions. Okay, so we'll discuss how to find phi and x, or A and B. Before that, one more thing we can write here is what? Your natural frequency is what? Under root k by m, right? Everyone, it is under root k by m. Now we already know from static equilibrium, your mg is what? K times delta. So you can write your k by m is what? It is g by delta, right? So you can write your natural frequency either under root k by m or under root g by delta static. Is it clear? In both the form, we can write natural frequency. Or if in your question they give just delta static, then also you can find natural frequency of the system. Now, guys, next is what? Once you know omega n, what is Fn? It is omega n by 2 pi. So we can write natural frequency in terms of hertz. Now from initial condition, as I told, suppose at t equal to 0, my x is x naught, initial displacement, and my velocity is v naught. Then what will be my capital X and this unknown phi? So how we can write? So guys, in this equation substitute at t equal to 0. At t equal to 0, substitute x equal to x naught. So what you will get? You'll get x naught equal to what? It will be capital X sine phi. When you substitute at t equal to 0, x naught equal to v naught. So first what we find, guys, from here, this is displacement. So how you can find velocity, guys? How you can find velocity? You differentiate this, you will find velocity, right? So what will be your velocity? It will be capital X into omega cos omega n t plus phi. Now at t equal to 0, what is your velocity? It will be what? It will be capital X omega cos phi. Am I correct? Now guys, I can write sin phi is what? Your sin phi is x naught by capital X. Am I correct? And what is your cos phi? Your cos phi will be x dot by, or x dot is what? It is v naught, right? At t equal to 0, your velocity is of what? V naught. So I can write it as v naught by capital X into omega. Now guys, I can square it. I can also square it and add it. So what you know, sine square phi plus cos square phi is what? We know it is 1, right? So do it from here. What will get? If you want to find your x, it will be what? It will be square root of x naught square plus v naught by omega whole square. Am I correct? We have got displacement, this amplitude part. Is it clear from this, guys, or not? Anything is missing? Yeah, here again x naught is coming. So anything I miss? No, it's correct only. It is correct, whatever I have written. Is it clear? Amplitude part, it is what? X naught square plus v naught by omega whole square. Now guys, once you know this amplitude part, what is next? You can find phase angle. How you can find phase angle, guys? Anyone? Phase angle? So we know already sin phi and we know cos phi, right? So you can find tan phi, right? Sin phi upon cos phi. So it is what? What was your sin phi? It is x naught by capital X. And what is your cos phi? It is v naught by capital X into omega n. So what you will get? Tan phi. You will get tan phi as x naught omega n upon v naught, or my phi is what? Tan inverse x naught omega n upon v naught. Okay, so this is what your amplitude and phase angle. Any doubt till here? Yeah, you can use other equations also. So you will have unknown A and B. But okay, that also. But here that equations you guys know, right? You guys know this one fact. One fact is what? You guys always can write sine A, cos A. That one thing is there now. Trigonometry. That is more about trigonometry. But this is more generalized equation. It is better to use this equation instead of that. So you know, right? Cos A plus B is what? I can open, right? Cos A plus B is what? Cos A, cos B minus sin A, sin B, right? It is something like that. Okay. Yeah. Now you can see these are the my amplitude formula, and I think anything I missed here, guys, in this formula. I think it is fine. So this formula is there. You guys can verify this. Okay. And we know phase angle. Now, once you know the phase angle, you can draw the response. So this response is depend on what? This is what the phase angle. So that's why you can see it's starting from negative x-axis. So there is a phase height, and this is what your amplitude of vibration. And then it is going and coming back. So it is kind of simple harmonic motion. Okay. Yes or no, guys? Any doubt here? So you can see this is the id. Okay, so this is what the phase angle means. If your phase angle is 0, guys, tell me, if phi is 0, from where your response will start? Anyone? If your phase angle is 0, your response will start from 0, like that. Okay, or not? Yes or not, guys? You can see here. This is what my equation. If phi is 0, so the your response equation is what? My response equation is x equal to capital X sine omega t. So what is the curve for sine omega t? Everyone knows it is like this. It is start from origin, it goes like that. Okay, when phi is 90 degree, anyone? When phi is 90 degree, what will be the response? When phi is 90 degree, what will be the response, guys? Anyone? What will be the response if phi is 90 degree? Phase angle is 90 degree. And when the phase angle will be 90 degree, anyone? When phase angle will be 90 degree? Anyone tell me? What is your phi? Phi is tan inverse. It is tan inverse what? X naught omega n by V naught. Now tell me, guys, when phi will be 90 degree? Anyone? When phi is 90 degree? So this is what the response. If phi is 90 degrees, so my response equation will be what? It will be capital X cos omega n t. So when phi will be 90 degree, anyone? What is current supply? When phi is 90 degree here, from this equation, anyone? When phi is 90 degree? Nikita, have you studied mechanical vibration?
Yes, sir.
So when phi is 90 degree, when phase angle is 90 degree?
सर ये आगे की साइड मूव कर जाएगा थोड़ा सा ये ऐसा ही बनेगा
नहीं ये तो बन तो गया. Curve is like this. Okay. This is what the when you have phase angle 90 degree, this is what your response equation, and this is how your response curve. Now tell me when phi will be 90 degree from this equation. For what initial condition? For what initial condition your phi is 90 degree? Anyone? Yeah, quickly anyone tell your equation is in front. When this will be 90 degree? Phi is 90 degree if it is tan inverse infinity, and when it will be tan inverse infinity if v is 0. Clear? So if your initial velocity is 0, then your phase angle will be 90 degree and your response will be x cos omega and t, and this is gate A question. This is from where gate A question is there. One of the question. I will give you this question. You see the question number 2, guys. It's visible, right? Is it clear why this phase angle is 90 degree from here? And when it is 90 degree, if your initial velocity is 0, then your phase angle will be 90 degree and your response will be cosine. So you can see if you substitute in this equation t equal to 0. If you substitute in this equation t equal to 0, what you guys will get? Tell me anyone. If you substitute in this equation t equal to 0, what you will get? You'll get x equal to capital X. So means the initially itself you are giving maximum amplitude, right? This is what, this is your initial amplitude, or you can say maximum amplitude is what? Your initial displacement. You can see, right? When t equal to 0, your cos will be how much? Cos 0 is how much, guys?
Sir.
1, right? So your initial amplitude is what? X naught. Now here, guys, so Nikita, now is it clear?
Yes, sir.
When phase angle is 90 degree if your initial velocity is 0. Now solve this question, guys. It is from GATE Aerospace. Question number 2. Read the question. What is given? A 1 kg mass attached to a spring elongate it by 16 mm. The mass is then pulled from its equilibrium position by 10 mm and released from rest. Assuming the acceleration due to gravity of 9.81 meter per second square, the response of the mass in mm is given by. Anyone? Try to solve this question. I am giving some time. Okay. Yeah, anyone? So look here, what is given? See the initial elongation, like static elongation they have given. Static elongation is how much? 16 mm. For what mass? 1 kg mass, right? Now, so that means what, guys? You can find the natural frequency. What is the natural frequency, guys? It is g by delta static. So guys, find out here natural frequency. So you guys read here, 1 kg mass attached to a spring elongate by 16 mm, right? So that means your delta static is given as 16 mm and your G is given here how much? 9.81 and 9.81 meter per second. Guys, find out natural frequency here. Anyone? Am I correct? It will be 24.76 radian per second. Yeah, right? So this is what your natural frequency, guys. Once you know your natural frequency, now what next they have given? The mass is then pulled from its equilibrium position by 10 mm. So that means your x naught is given as 10 mm and they told release from rest. So what is the meaning of release from rest? Your initial velocity is how much now? If it is released from rest, anyone? It is 0, right? So your
Yes.
initial velocity is 0 and your initial displacement is given. So what will be your response equation? It will be x naught cos omega n t. Am I correct? This is what we have already discussed, right? When your initial velocity is 0, your response equation is what? X naught cos omega n t, right? Here you can see this equation and your capital X is what? X naught. So tell me what is the answer, guys, here now? What is the answer? Yes, option B is the answer. Clear? So how easy questions and based on your proper concept learning. Yes or no? Was this question tough? Say yes or no. So this is how we discuss concepts. Okay, every basic is covered and then we go one by one related question. Is this method fine? You guys understood? Any doubt here in this question, guy?
No, sir.
Anyone? Nitin, Abhishek, Shreya, or Manikandan, Ishwar, Abhiram, anyway you are writing. Anyone has any concern or question here? Tirth? Okay, you didn't get the calculation part 24.7. What is your natural frequency formula in terms of delta static? What is the delta static here? If you read this question, see a mass. Okay, this mass can elongate this spring by how much? Delta static, right? How much delta static it is given? 16 mm. And we know the natural frequency formula in terms of delta static, it is what? G by delta static. Can you solve this and tell me how much value we will get? G is given 9.81 and 16 mm. So make sure you convert the unit in SI. So what will be the, if you convert unit in SI, it will be what? 9.81 divided by 16 into 10 to the power minus 3. Sejal, now is it clear? Baswati. Baswati, is it clear? Are you understanding what I'm talking? Okay, so is it clear, Sajal, now? Okay. Now, look here, one more question. The first question, the number of natural frequency. The number of natural frequency of an elastic beam with cantilever boundary condition. What is the answer, guys?
Finite, sir. D.
Yes, it is infinite, right? Because your cantilever beam is what? Continuous system, and number of degrees of freedom will be how much? Infinite. Okay, is it clear? Is it clear to everyone?
Yes, sir.
Yeah. So let's see one more questions. It is next question is also from previous concept. What is given? X double dot plus 3x equal to 0, and your initial conditions are given. X at t equal to 0 is 1, and x dot at t equal to 0 is what? 0. So that means this is velocity is 0. Your initial velocity is 0, and this is what your initial displacement. Now they asked at t equal to 1, what will be your response? So what is first thing we have to find? We have to find the response equation, which will be what? It will be x naught cos omega n t. What is our omega n, guys, here? It is under root 3. All right. And what is your x naught? It is 1. So we can find at t equal to 1. What is your equation? What is your response? It is 1 into cos. Guys, one more thing. You make sure you convert. When you find the angle, this is in radian. So you either keep your calc in radian or you convert in degree. Tell me the answer, guys. 1 cos under root 3. 1 into cos under root 3. How much the value? Or the value of cos under root 3? You, I think, Abhiram, you only facing due to internet.
0.16, sir. Minus 0.16, sir.
Minus 0.16, exactly. Yeah. So that is the correct answer. So what is the answer? B is the answer. Now, guys, why I wrote directly this equation? I didn't use this equation, right? What is that generalized equation? X sine omega t plus phi, right? This is what my generalized equation, right? Why I didn't use, I wrote this because I know already from initial condition, when initial displacement is non-zero and velocity is 0, my response equation will be this. Is this clear, this point? And is this question is clear? Everyone got the answer? Cos under root 3? Yes or no?
Yes, sir.
Okay. So how you guys want me to explain few more things, or this is fine? Because this is just demo. We are not in a regular class. Are you guys getting interest while solving questions? So let's do one more question, which is again further a good question. Question number 4, based on the similar concept. Read the question, guys. What is given? One of the linear spring is attached to a fixed support and a mass of 2 kg hangs from it At other end, a force of 4 Newton causes a displacement of 0.002 meter. The mass is pulled down a distance of 0.004 meter from its static equilibrium position and released with zero velocity. You all can see this question. So again guys, the initial force 4 Newton causes what displacement? 0.02 meter. Okay. So guys, what is your natural frequency? So first what we can do, we know F is what? K times delta. Find K value. So what will be K value? Because they didn't mention G value. So it is better find K value. So my K is what? F times F by delta. Right? What is F given? F static force is given as 4 Newton and your delta is given as what? 0.02 meter. So guys, tell me K value. Tell me K value, guys.
200, sir.
200, sir.
Okay, 200, right? Now, what is natural frequency? It is under root K by M. So find the natural frequency, guys.
10 radian per second.
10, sir.
Right. So D is the answer, 10 radian per second. Everyone, please solve this first part. So here I will tell, here there was one typo here. Here this should not be x, guys. Okay. In this equation, it is what? X naught square plus V naught by omega n whole square. Okay. So in typing here, typo is there. So keep it in mind. This is what my displacement equation. Yeah, now we are solving this question. So let be here. So omega n, everyone please, it is 10 radian per second or not? Yes or no, guys? Right? So once you know this first part, let's see the second part, which is more complicated or better. So what is the second part they told? The magnitude of velocity, the magnitude of velocity when the body has moved halfway towards the static equilibrium position from its initial position. So what it means? Suppose this is what my mean position or equilibrium position, and this is what your initial displacement. Now the body is at this location, at half location. So that means what? At some time t, your x not your x is what? X naught by 2. At some time t, your x is equal to x naught by 2, and they ask what is the velocity? Unknown. Okay, so how we can find? It is very simple, guys. We already know, right? What is the equation when the body is released with zero velocity? My response is what? X naught cos omega, my cos omega n t. Okay. Now guys, they told at some time t, your x is what? X naught by 2. So substitute here. So from here, what I will get? I will get the value of cos omega n t. So from here, my value of cos omega n t is how much? Anyone? How much it is? 0.5? It is 0.5, right? Yes or no? Yeah. Okay. Now, guys, they ask the velocity. So we know the what is the velocity formula? My velocity is what? When it is a cosine, right? So my velocity will be what? Minus x naught omega sine omega n t. So I can write it as what? Minus x naught omega 1 minus cos square omega n t. Am I correct? Now cos omega n t is already known. It is what? 0.5. Your x naught is known. How much it is? 0.04 meter, and omega is known. How much? It is 10. So find the velocity, guys. So it is 0.04 into 10 into 1 minus 0.5 square. So tell me the velocity. It is not divide. Okay, it is multiplied. This term is in multiplication. This entire term is here multiplied.
0.346 meter per second, sir.
Exactly. What is your name?
Nisha, sir.
Yes, Nisha. So you are in second year right now, right?
Yes, sir.
Yeah, so you can appear in GATE 2022 also, and it seems you have good concepts, so you can do it. Okay, because from IGC a third year student got rank 113 and one more person 134 in their third year. Clear? One student is from Amrita Coimbatore and another from BMS College Bangalore. So in your third year also you can get good rank. In our time, one of my junior in third year got rank 54. Okay, in 2008 in third year, because that time also third year students were eligible. Now it is clear to everyone what is the answer. So I can write here again. What will be my velocity when your x is x naught by 2? So it is minus 0.04 into 10 into under root of 1 minus 0.5 square. Yeah, tell me the answer, guys, everyone. Hey, why we are multiplying by 10? What is your formula? Velocity. It is minus x naught omega into sine omega n t, right? So how much is omega? It is 10, right? Yes or not, guys? Is this question is clear or not?
Yes, sir.
Others? You are from which college, Nisha?
Sir, I'm from Alliance University.
Alliance University, Bangalore, right? Yeah, we have produced a good rank from Alliance University also. We have one guy in ISC Bangalore, one in IIT Madras from Alliance University. Okay.
Actually, I have a doubt, sir.
Yeah.
Sir, now I'm in my second year, sir. So if I join the class, which is going to be on May 2nd, sir.
Yeah. So
What's
first
up,
year
sir?
itself, 100% syllabus will be completed by mid of December. So you can write GATE exam easily. And next year again, if you want to improve your performance, you can go through classes back.
So
You will,
it is
so
from
this year
basic
fee is 25,000. Next year fee is 15,000. 10,000 concession will be given next year. Yeah.
So it will be from basics only, sir, right? Even
So
if
this is whatever we discussed today is not from basics. Have you guys learnt vibration subject prior?
No, sir. In my college, they didn't taught me this.
Yeah,
In
but
school links, I have did.
yeah, so this is how we do. We will discuss all the basics, related concepts, and then we solve the related questions. So this is what my approach, and our all other teachers' approach also same. Yeah, so anyone has any doubt here? So we'll wind up. So here, and I have covered few basics, and it is response of single degrees of freedom system, spring mass system, and here I discuss the different cases when you have non-zero velocity, when you have zero velocity, or when you have at phase angle, zero phase angle or 90-degree, or you have some phase angle. So here you can say both my velocity is also non-zero, my initial displacement also non-zero. So this is what my x, okay, and it is what under root of x naught square plus v naught by omega whole square. And my response is what sine, I can multiply it to sine omega n t plus phi. Okay. So fine, guys. Can we stop?
Fine, sir. Thank you.
Yeah, thank you. And anyone has any technical, non-technical doubt related to our classes? Vitul, you were there in class throughout? Yeah, Tirth, you have any concern? Shreya or Nikita?
No, sir.
Nikita, I was expecting answers from you, but I didn't get. Sorry, but I wanted. Okay. You are from
Okay,
RTU,
sir.
right? You are from RTU, right, Nikita?
Yes, sir.
Yeah, so you should, answer quickly.
Yes,
Okay.
sir.
Yeah, that is what my expectation. Yeah, Khushbu, Bashwati, you were inquired last time also, Bashwati, if I remember.
Sir.
Yeah, you inquired last time for test series, if I remember. Your number was saved. Okay. Anyway. Yeah, Vitul, any concern? Tirth,
No, sir.
Tirth, you are from which college? And one more thing I want to share. This IGC will be mini India, because here students will from across India from different colleges. So you guys can have, a good bonding. And in this negative situation, a lot of bad things are happening, right, due to COVID. So this gives us, the positive vibe when we, at least meet people from different places and from different colleges. So this can, it can have a good vibe. Like you guys can cherish these vibes when lot of negativities are there around. Yes. So anyone has any concern? Any non-technical concern about classes or any part? Can write quickly in chat box if any. Yeah. What I mean by term response exactly. So response means what? Your deformation, right? When or motion. See, when vibration is happening, right? This free vibration is happening, right? So you can see at any point you want to know what is the displacement, what is the velocity, what is the acceleration. This is what your response. So you need to write, these are in terms of equation. So at any time you can find, or at any point you can find what is my displacement, what is my velocity, like that. Is it clear? The response mean? So everyone understood the last question where they ask the velocity to find here.
Sir?
Yeah.
Sir, is it answer B? Last
Yeah,
one.
B is the answer. 0.346. Right? 0.346 is the answer. How velocity equation came? See what displacement equation? It is x equal to x naught, sorry, not x dot. It is x naught cos omega n t when your initial velocity is 0. Now we know what is the velocity, guys. Anyone? It is dx by dt. So can you differentiate this equation? So what we'll get? We'll get x naught omega n, and you'll get minus sine omega n t. So what we got? Minus x naught omega n sine omega n t. Clear? Is this clear now? Yeah, fine. Yeah. Anyone? Anyone else has any concern? Okay, okay. So thank you guys for joining this session, and we will wind up now. Thank you all.
Thank you, sir.
Thank you.
Thank you, sir.